Hi, this is David Vallo, and I'll be doing the introductory part for our group project. We are Group 11, also known as Math Fun. A quick rundown of our agenda for this presentation. We'll firstly go over our introduction, or basically some logistical data to help you understand how we worked on this project. And then moving on, we're going to talk about the requirements. How do we collect them? And what are the different individual requirements of each stakeholder? And then afterwards, we'll go through a walkthrough of our prototype and application, and finally sum and wrap it all up with our testing, survey, and maze project. So please look forward. Now, a quick introduction where we take you through our group project process and the logistics of it, and as you can see over here, this was taken while we record this presentation. Given the design of the task, we decided to tackle on the project task by task, starting off with the requirements, and then designing the prototype based on those data, finally testing it with our participants, and then recording this video. Over here is a very quick little overview of our scheduling on how we worked on this project from the beginning up till the very moment of submission. Now, with that quick introduction out of the way, let us see you at the app. Haha, before we actually get to the app itself, we gotta find out the requirements, so let's go over that. The most important part when you're setting up the requirements is first how do you get the requirements, especially since it doesn't make much sense if we ourselves decide what the requirements are without fully understanding our user base. So how do we do it? There are different questionnaires and surveys and different face-to-face interviews as well as on-site demonstrations of different applications and prototypes where we're able to discuss with the three main stakeholders and determine what the requirements are. Before taking a look at the actual requirements, please keep in mind it is important to remember the difference between functional and non-functional requirements, as it will guide us and aid us in our development process. From the student stakeholder part, the requirements consist of 5 major functional requirements and 5 non-functional requirements. Going over them, for the functional requirements, we have a platform, engagement, feedback loop, social features and collaborations, and adaptive learning. Regarding the non-functional part, we have visual representation, user profiles and customization, accessibility features, cooperation mode, as well as information. As you can see, the non-functional requirements are actually supplementary functions towards the main functional requirements that in order for the app to run. A few functional requirements I would like to lightly touch on to give you more information, especially engagement. The engagement aspect is very important, as students have found out that through these different types of educational apps that they've tested out during our interview phase, they don't really get hooked onto it. And although their motivation to do it is high, their determination to keep going is pretty low. And one aspect we can do this is by dynamic application. Something as basic as motion regarding the answers they chose can significantly improve the engagement that the students have. Social features and collaborations were also a very unique trait that we've discovered, as thanks to the advent of technology, students around the world have an interconnected feeling and want to share that experience to make sure to feel like they're not alone going through it. And the last part, adaptive learning, I think is very essential to this application, in which the application can adapt to the student's progress and skill level, so that way they won't have to feel far behind. From the teachers and educators' perspective, they have 3 functional requirements, which include a progress tracker and report system, one that can analyze and gives a summary and data back to the teachers to properly determine the student's progress, a guidance system, in which previously we've mentioned that students want an adaptive learning system. The guidance system directly manipulates that gives teachers access to manipulate what kind of further learning and further practice students need. This way, the teachers have access to the progress tracker and report that can help them identify what kind of guidance students need. And lastly, the teachers want a parent-teacher communication chat box to directly communicate with the parent to see how the parents can help on the home front. Some non-functional requirements include a cross-platform transferable data format, because teachers have mentioned that they have different platforms that they all use and would love the data to be transferable. Secondly, they want a multimodal learning support, in which that the main way that the students engage with the learning can be not just an MCQ but different kinds of formats. And lastly, teachers would prefer if there's an offline functionality in which they can continue working on the progress tracker and report without internet connectivity. And finally, we have the parents and guardians stakeholder requirement. For parents, one very direct and straightforward, yet also obvious control they would like to have is the parental control, to be able to limit their children's uses in case they get too addicted or they want to reduce their amount of screen time. A second thing would be a performance analysis. Similar to the progress tracker that a teacher has, the performance analysis measures more on the student's ability to reenact what they learned instead of the student's engagement and progress in learning a topic. And lastly, the last functional requirement parents would like to have is a parental dashboard for all the important information that parents need to know to determine their children's progress and performance. Some non-functional requirements include secure data management. As a lot of parents are not as tech savvy or tech literate as the developers, they would want to have some sort of guarantee and reassurance that the data is secure, given that this is their children's own personal data. Secondly, they would like to have a proper and robust customer support system, given that, as mentioned earlier, parents and guardians are not usually the most tech savvy or tech literate. And lastly, they would like to to have a notification and update system that can directly reach the parents. Now, these are all the requirements of both the teachers, the parents, as well as the students. Now, let's take on the time to see how we designed this based on all the data collected.
This is Zheng Shouwen. Tai Chi and I will be introducing you part 3, the walkthrough of FunMath.
Hello everyone, I'm Zheng Shouwen, and this is my student ID number. And this is the prototype of our project. As you can see, this is our study library page. There are many courses for children in this page. And we divide it into different content: addition, subscription, multiplication, and division, and all the contents. Now let's click on a random course. There are different classes for students to complete. Then we click in the core class, and there are 3 parts: video module, material module, and a practice module. And what I want to mention is that we have schedule model, and we can see time class schedule here. Now let's move to the community page. This is the home page where children will have friendly conversation and like post and have a talk. And this is the homework page. Here, teacher can assign homework for children to complete, and we can access more detailed job page. We can see in detail the number of people who have not completed each assignment and the submission method. This is the post page in our community. Each post will be received to ensure the psychological safety of the children.
Hello everyone, I'm Zhou Taiqi, and this is my student ID. Okay, I will introduce the game part and the user part for you. First, user part. Users can select a mode after entering the game interface. We have 2 modes: adventure mode and the little game mode. After entering the adventure mode, the user enters the page for selecting levels and difficulty. The user selects the difficulty here and the level here. After selecting, you can enter the game interface. Multi-apply choice questions are usually suppose a very storytelling scenario. The images and dialog boxes at the top of the screen will perform a simple plot interpretation. Once the corresponding problem occurs, the corresponding option will appear below, and a countdown progress bar will appear in the center of the screen. If the user selects the correct option with allotted time, the plot can continue. If the user wants to save or exit during the plot, this can be done via 2 buttons on the screen. Select on the left the return to the level selection interface, and select the right to save progress. Users can also choose 4 mini games. Mentalize shouting game, mass racing game, addition streaks game, and simple tower defense game. In the Mentalize attack game Star War, Mentalize with arithmetic expression appears randomly on the screen and approaches the as below. The user needs to enter the answer corresponding to the calculation formula. In the input box before the Mentalize falls to the earth. Then a laser will appear on the screen to crush the meteorite. Depending on the number and speed of the smashed meteorite, users can get different points. For mass racing games, the car will encounter obstacle written with a mathematical expression during its operation. At the same time, the corresponding option will appear at the bottom of the screen. After the user selects the correct answer, the car will continue to move forward. Depending on the number and speed of the player passing obstacles, different points can be got. If the user does not understand how to play the game, he can click on the help interface in the upper left corner of the page. And last, we also designed the achievement interface. If the user triggers some special conditions during the games, he or she can obtain specific titles or medals. Now let's go into the user module. Sorry. Okay. Next, let's look at the user interface. The user interface displays some basic information about the user, as well as some personalized program settings. We first enter the profile interface, where users can edit their avatar name, birthday, and run social accounts. There is also store function here. Users can be used to redeem some useful simple school supplies here. In addition, we also have the analyze report function. This feature is only available to parents. Parents can see their children's learning progress and status here. Okay, that's all for my presentation. Thank you.
Now, the final part of our presentation, testing. The objective of the testing phase is to ensure good design philosophies are being followed in our development, whether or not the application was intuitive to use and the ease of use of our application.
Hello everyone, I'm Huang Tianqi, and this is my student ID card. I will introduce Maze. It is used for the test result of the interface. We use the Maze to test our interface. The PPT displayed the overall result of the interface test. We invited 20 testers to experience our design. Their direct success rate reached 54%. To thoroughly test our design, we divided the main functions into 4 parts according to the requirements: study, game, community, and user features. We designed a task for each function that best exemplified its role for testers to execute. For the details of the tasks, we considered all possible strategies to achieve the outcomes. Testers were deemed to have completed the task when they reached the specified page based on the task description. We measured their click speed and sequence during this process to assess our test results. As shown, the test result for the study section indicates a direct success rate of 85%. The image on the right is a heat map representing the distribution of interface click frequency. We found that users tend to use random arrow testing to try out the content at the center of the interface. The image shows the test results for the game section, with a direct success rate of 45%. This no figure may be due to the variety and complexity of game types. Testers may not have fully understood the task requirements, or the test design coverage was low. The image presents the test result for the game section, with a direct success rate of 50%. The value is relatively low, and the arrow click rate is high. This may be due to certain features in our design that have not been implemented yet, which testers frequently attempt to use. This reflects that our design requires further improvements in subsequent iterations. The image displays the test results for the game section with a direct success rate of 70%. This rate is relatively normal, but the arrow click rate is high, which is also due to some unfinished features in our design. Additionally, as this was the final phase of testing, consider the extensive nature of the test tasks. It's possible that some testers experienced a change in mood and stage, affecting the test result.
Hello, this is Zhang Zhiyuan from Group 11, and my student ID is 2109641D. And I will be introducing you Part 4.2, Survey. There are 3 stakeholders who took our survey: 1 primary school student, 1 parent, and 1 mathematics teacher. After finishing proper progress, all of them give 5 out of 5 to our FunMath. They have verified and validated the requirements set up have met their respective expectations. And all our stakeholders who took the survey are able to accomplish the tasks they intended. Some mentioned that there are some features were inaccessible, but it's still an inviting prototype. Our stakeholders have also mentioned the most helpful design from their perspective. To summarize, the testing of the prototype was a major success. General good design philosophies and principles were observed and proven in the form of an intuitive and easy-to-use UI design. That's it for our presentation. Thank you very much.